This is lesson 6.3. It will lead you towards chapter 6, day 2 worksheet. This lesson is about arcs and angles. We'll get a few definitions out of the way. They're on your chapter 6 term sheet. And then do some practice problems associated with the different properties of our arcs formed on our circles and our angles inscribed on central angles. First definition, the measure of an angle inscribed in a circle is blank the measure of the central angle. Remember this, if we call this circle, let's call it circle X, CXR is the central angle, CAR is the inscribed angle. The measure of an inscribed angle in a circle is half the measure of the central angle. Therefore, if this is 100 degrees, the measure of angle CXR equals 100 degrees. Therefore, because of this property, the measure of angle CAR is equal to 50 degrees. This would be 50 degrees. Don't forget that the measure of the intercepted arc of a central angle is going to be the same as the central angle. So this arc CR is 100 degrees, which makes major arc CAR 260 degrees. Another example, what is the measure of the inscribed angle? If this is 98 degrees, we have to be half of that. This would be 49 degrees. This little minor arc right here would be 98 degrees. The central angle is equal to its intercepted arc. The inscribed angle is half of that. Inscribed angles that intercept the same arc are congruent. So if you take a look at what we've got up here, I've got this 15-degree angle at AQB. If AQB is 15 degrees, that means its intercepted arc would have to be 30 degrees because it's going to be, the intercepted arc is going to be twice as much. Take a look over here now. When we go up to this one right here, APB, not very well drawn there by me. That's okay. That's going to also be 15 degrees. So I get 15 degrees for this one as well. The other one, if this green arc right here is 40 degrees, then we're going to be able to find PAQ and PBQ. If we have PAQ intercepts this guy, this has got to be 20 degrees, and we have PBQ would also have to be 20 degrees. So if an inscribed angle intercepts the same arc, they're going to be congruent to one another. Another example, if PAQ is 17 degrees, arc PQ has to be 34 degrees. If this is the intercepted arc, we cut it in half, 17 degrees. Again, they're intercepting the same arc, they have to be congruent to one another. This little guy here, I've got 23 degrees down there. This would have to be 46, and this would have to be 23. So to answer these questions, what are the measures of APB? APB is 23. It has to be the same as AQB. PBQ is 17. Has to be the same as PAQ. What is the measure of arc PQ? 34 degrees. Inscribed angle properties. Angles inscribed in a semicircle are right angles. Let's take a look at what this looks like if we were to draw a couple of these up. If I threw a right angle here to there, you can almost see it visually, but if you think about the fact that the semicircle is 180 degrees and the inscribed angle is half of that, we can draw another one here where we obviously get 90 degrees. We can do it again 90 degrees, and you can really kind of start to see a pattern in terms of the 90-degree angles from our inscribed in a semicircle. Same thing happens on the opposite side, here and here. Cyclic. Cyclic is a new term. A quadrilateral that's inscribed in a circle is said to be cyclic. And cyclic, the opposite angles of a cyclic quadrilateral are supplementary. So we've got these two guys are opposite, and they're going to have to be 180 degrees, and these two guys are going to have to be 180 degrees. Remember, if you're inscribed, if a quadrilateral is inscribed, the circle will touch each of the individual vertices. Inscribed is inside. Parallel lines intercept congruent arcs on a circle. Congruent arcs on a circle. If you think about the idea of parallel never intersecting, they're going to have to go through an arc that's going to be the same. So if this is 32 degrees, this one over here would have to also be 32 degrees. Some practice that we can get through here. Let's take a look at what we've got. The biggest, one of the biggest mistakes, not mistake, but one of the things that students tend to miss quite a bit is when we have a diameter. Please remember, when we have a diameter, you have to have 180 degrees because it's a semicircle. So you can start filling stuff in right away here. If that's 80, then this has to be 100. If this is 80 and this is the inscribed angle that forms it, this has to be 40 degrees. It also says that we want to find, let's see, measure of angle XNM. X to N to M was 40 degrees. We found that one. The measure of arc XN. X all the way to N is going to have to be 180 degrees. Notice that's going to be 180 degrees no matter which direction we go. Remember, a minor arc is less than 180, would be named with 2. A major arc is named with 3, but obviously, no matter which direction we go to XN, it's going to be a semicircle for sure. And then MN, the state you live in, also is 100 degrees. Notice we don't have enough information to deal with those two separately. We could just deal with that half that has the semicircle based on the information that was given. Next one, this is 120 degrees. So we work with all of these inscribed angle theorems. Please don't forget that the central angle is equal to the arc that it intercepts. So I've got this 120 right here. This X has to be 120 degrees. Don't forget about the central angle theorem. Now, the central angle, it has to have a center at the center circle. So I've got 120 degrees here. That would mean this is the inscribed angle that forms that 120 degree angle. It's going to be half of it right there. Notice this says AB is a tangent. If this is a tangent, this is its point of tangency. These three together are going to have to add up to 180. So Y has to be 60 degrees. 60 degrees. And then we've got this guy right here where we've got a we're here, and then we're out. This is still, whoops, this is still an inscribed angle. And we have 60 degrees, so Z has to be twice as much of it, 120. This would also be 120 over here. So this is very symmetrical. So Z is 120 degrees. Notice 360 all the way around. I got the 180s there. And this point of tangency, if this is 120, 60, 120, 60, 120, 60, should not be surprising to us. Next one, it says here we've got AD as tangent, so I've got A as a point of tangency. If A is a point of tangency, let's not forget about the stuff that we learned in 6.1 and 6.2. Then this has to be a right angle. Notice this is a radius, AO is a radius, So that's a right angle. Now you take a look at the first question they asked us. Angle A is going to be 90 degrees, and you can see that DAC is going to intercept that 180 degrees, half of it 90. We also are going to be able to find angle C. I have a triangle, 90 and 54. If we have an acute 54 here, this probably is going to be 36 degrees. So angle C is 36 degrees. We can tell a few things more about our measure of arc AB now. Notice 36 degrees is going to be the inscribed angle for the arc AB, which means this has to be 72 degrees. 72 degrees. And then we can tell CB is over here. Again, don't miss the diameter. Diameter means that we have a semicircle. If AB is 72 degrees, CB has to be 108 degrees. So the right angle, because of the point of tangency, gives me a triangle. This triangle is going to be an inscribed angle for that 72. Next example, this is on one of your day sheets, and it's a kite, obviously. We've got our consecutive, we've got our double ticks, and we've got our single ticks. We also have a cyclic kite. Remember, a cyclic kite is going to have the opposite angles are going to be supplementary. Remember, we have right angles in here. The vertex diagonal is the perpendicular bisector of our other diagonal. So I've got angle W has to be 90 degrees. I'm going to change colors here. Next thing I know, 134 degrees. 134 degrees. Notice that's an arc intercepted by this angle V. V is going to have to be the inscribed angle that forms the 134. So all we need to do is cut that in half, and I will have 67 degrees. So that's a 7. 67 degrees. So V is 67 degrees. This is the center right here. Since this diagonal is passing through the center, I know that if this is 134, X and 134 have to be 180 because of that diagonal that is also the diameter. The diagonal is the diameter. So I've got 180 minus 134, and we get 46. So I get X is, 46. X is 46 degrees. 46 degrees. Let's see, we can now, since I have 46, and you take a look at the diagonal forming Z here is inscribed, it's going to have to be half of 46, which means this is 23. If this is 23, I know that the vertex diagonal of a kite is bisecting the angles, so that means this has to also be 23 degrees. Which brings me up to A has to be 46 degrees. So we've got quite a few things filled in. Again, this is a diagonal, that's 46. B is going to have to be 134 degrees. Head over here, fill in. B is 134. A is 46. What else do I need to find? C, angle C. C is going to also intercept the 46. Notice my angle down here, which forms that 46, which was A, intercepts there. I also have over here forming my 46, so I know that this is 23 degrees again. C is 23 degrees because it's inscribed intercepting a 46. We also have this big guy right here is intersecting the end of the diameters, which means that has to be 90 degrees. So there's a bunch of different ways we can get these results. So this is going to be 23 degrees here. I know this is a right angle. Y is going to end up being, I could look at it as half of my 134, or I could look at it as 23, and 90. So I need a 90 minus 23, which must be 67 again. So y is 67 degrees, and z was 23 degrees, and I think we found everything that we were looking for. So remember, the inscribed kite here would be cyclic. We also have an intercepting the diagonal, which made these two right angles. This 46 and these two together would be 134, and of course I've got congruent triangles as well. Quite a bit going on there. A little bit of an easier one here. I look at this, I see a diameter, which means A has to be a right angle. I see this 70-degree arc right here, which means this has to be 35. If that's 70 and the two of these are 180, this has to be 110, which makes this 55. So C is 35 degrees, B is 55 degrees, A is 90 degrees. Next one, please note that we do not have a diameter on this one, so you want to watch out for that. I see 140 here, and I see this being the arc, so I have an inscribed, which makes C 70 degrees. I see this as 100, which means half of 100 is going to be 50 degrees. If this is 70 and this is 50, I know from the fact that it's a triangle that it has to be 60. I also know that 140 and 100 gives me 240, which means this would have to be 120. So the fact that we get 60 here and 120 there, coincidence? Oh, I think not. A is 50, B is 60, C is 70. Next one brings us back to our 6162. Please remember that we have an exterior point that is tangent to the same circle. Then this is going to be congruent to this. Notice this is a radius and that's a radius. These two are also congruent. We form a kite every time we have one of these. Point of tangency forms a right angle, which means I got a 90 and a 90. Remember, if we have the kite with the two 90s, this is 40. This is going to have to be its supplement. This 72 is in the wrong. This is incorrect. Let's get that out of there. If this is 40, whoops. If this is 40, this has to be equal to 140. Excuse me, 140. 140 and 40 have to be the 180. There's my two right angles. If that's 140, that's a central angle. This is its intercepted arc. 140 over there. If I have this major arc, then for y is 360 minus the 140, gives me 220. So to fill in our answers, x has to be 140, y has to be 220. My guess is this was supposed to be z here, so that's going to be 140. I got a triangle. I don't know if this is a diameter for BD. Kind of looks like it, but I don't know if it's going through the middle or not. 80 and 70 is 150. That leaves me with 30 over here. I can inscribed angle of 30, double it. I get 60 up there. 70 inscribed angle over here, 140. 80 is the inscribed angle for BD, makes this 160. We got everything filled in before we even take a look at what questions they're asking. Measure of arc AD has to be 140 degrees. Measure of angle D, 30 degrees. Measure of arc AB, 60 degrees. Measure of angle DAB, measure of arc DAB, D through A all the way to B, major arc, 140 plus 60, 200 degrees. I have congruent segments. Remember from 6.1 and 6.2, if we have congruent chords, the segments here, then I know that S and Q have to be the same thing. Common mistake here is that people want to make 87 degrees. They want to make Q 87 degrees right away, saying this is the center. It could be 87 degrees on a coincidence, but it also may not be 87 degrees. If this is 87, this is 87. I look at this 29. that 29 needs to be doubled. 29 times 2 is 58. So I know that R equals 58 degrees. Now, 87 and 29. 87 and 29 is 116. And so the third angle of this triangle is 64. 64. Now, I've got another inscribed angle, 64. In order to find P, I multiply 64 times 2 and get 128. So right now I have P at 128 degrees and I have R at 58 degrees. The 128, the 58, the Q, and the S have to add up to 360. Remember, we said Q was equal to S because of the fact that these chords are the same. And if you have chords that are the same, their intercepted arcs will also be the same. So my 128 and 58 total 186. I can take my 360 minus my 186 and get 174 divided by 2 and 87. Now I said this could end up being 87, both of these. That doesn't mean that they'll allow it. This is not a central angle. So we're not for sure that this will always be the case if we have basically a set of vertical angles. If they're not intersecting at the center, it does not make them a central angle. So you got to check that each time. Next one, I see 31 times 2 is 62 degrees. I see that. I see this as a diameter, which means y is going to be 180 minus 62 degrees, or 118 degrees. I see this as 84 degrees, which makes this arc 96 degrees. Again, look for the center, look for the diameters. 96 divided by 2, 48 degrees. I think I have everything I need. W, there is no W. X, 48 degrees. Y, 118 degrees. Z, 62 degrees. Hey, let's call this one W. W is 96 degrees. Remember, if we have a radius intersecting a tangent, that's a right angle. If this is 34 degrees right here, that's what that arrow is saying, and this is 90 degrees. Again, we're looking for this arc. That X is an arc right there. I got a 90 and a 34, which means this has to be 56. That's the central angle. X is 56 degrees. Okay? That's the arc right there. The central angle, 56. Y is the rest of it. 360 minus the 56 is 304 degrees. Okay, now the difference between this one and the one that we had a couple of slides back is that's definitely the center. Whenever we have a center, we have a couple of things. These radii are all the same, which means we have isosceles triangles, which means I can find A and X and Y and B very quickly. 82 degrees, 180 minus 82 leaves me 98. These have to be half of 98. So A is going to be 49 degrees. X is also 49 degrees. 180 minus 96 leaves me with 84. Cut them in half, 42 degrees. Again, look for radii. They're isosceles triangles. 82, central angle. Central angle. Let's slide this down. 82, that makes this 82. Z is 82. 96, I get 96 up here. So I've got, what are we looking for? Z is 82 and A is 49 and W is 70. W is 70. C we'll find in a minute. X is 49. B is 42, Y is 42. These are all degrees. And the last one, we can either do it with these four in here have to come together to be 360, so I can do 96, 82, and 70, which is 248, which means we're missing 112 degrees, and this is 112 degrees. all the way around the circle also has to be 360, so I get 112. Remember when we have a quadrilateral inscribed inside a circle, it's cyclic. That means that the opposite angles are going to be supplementary. So immediately, if that's 90 degrees, this is 90 degrees. W has to be 90 degrees. I also can see that if this is 90 degrees, it's intercepting 180 degrees. So if that's 126, this is going to have to be 54 degrees. So V is 54 degrees. Same thing going on here. This W is 90, which means these two together have to be 180, which means X is 109 degrees. I still have to find Y and Z. I can take my 71 and 54 and put those two together and get 125 divided by 2. Z has to be 62 and a half. Again, this is 125. Z is inscribed. I get 62 and a half for Z. I've got options for finding Y. The best one would be if these two are 90. Remember the cyclic, supplementary. Y and Z are supplementary. So I can do 62 and a half from 180 leaves me with 117 and a half. This is 117 and a half. Cyclic quadrilaterals have the opposite angles supplementary. Okay, I'm going to stop there. This big guy is kind of fun. So if you want to pause it and find all of these angles, if I was looking at this, there's a couple things that are important. L1 and L2 are parallel, which means N and H are going to be the same right there. We also have a bunch of central angles in here. Remember, radii are the same. Oh, if that's 25, that's 25, and so on and so forth. You can go ahead and do that one on your own. Hopefully you enjoyed your 6-3. You can get to work on your day 2 now, your day 2.